Chapter 14 discusses complex numbers, and for this class we're only going to cover section 14.1. You'll cover the remaining section in your later classes. So, the first thing we need to talk about is what it means for a number to be complex. Now, I'm sure you know the real numbers, the counting numbers, the irrational numbers, the rational numbers. All of those fit into the real numbers. Complex numbers come into play when we deal with the square root of -1. So the imaginary unit, typically labeled as I, your textbook uses J, is just the square root of -1, and this is just another set of numbers. But this is the imaginary unit. The reason the textbook uses J is that because in the field of electrical or electronic engineering, I stands for current, and as to not confuse the two, since imaginary numbers most often come up in electronic applications, they chose to use J as the imaginary unit. So anytime we have an imaginary number, this is just a number of the form BI, where B is a real number. And so those are the numbers that we're more used to. Now, if we add to this imaginary number a real number, then we end up with A plus BI, which is a complex number, again, where A and B are real numbers. And this is also called the rectangular form of a complex number, because we can think about this in graphical terms, which we'll talk about at the end of the section. So, just to simplify and recall how we work with these numbers, and we work with radicals, we end up with the square root of -49 can be split up as the square root of -1 times the square root of 49. Well, we said that the square root of -1 is I, square root of 49 is 7, and typically we write this as 7I. Now this one's simplified nicely, and the next two won't be quite as nice as this one. So in this case, -32 is not a perfect square. We can split it up into its perfect squares, namely 16, and then it has a remainder of 2. And so in this case, the square root of -1 is I, the square root of 16 is 4, and the square root of 2 stays as such. And typically we write this as 4I root 2, just so we make sure that it doesn't look like the I is under the radical. So I want you to try example C here, square root of -20, and simplify. So you should have gotten this one to simplify to be 2I root 5. Now we also need to talk about the powers of I. We talk about powers of any other number. We need to talk about the powers of I, or J. So first of all, again, remember by definition, I is the square root of -1. So if we square I, then we are squaring the square root of -1. And again, square and square root are inverse operations, so they cancel each other out, if you will, and you are left with -1. So I squared can be simplified to be a real number that is -1. I cubed we can split up to be I squared times I, to the first, because 2 plus 1 is 3. And we just said that I squared was -1. We keep I as it is, and so this ends up being -I. If we keep going with this, we end up with I to the 4th, which we can think of as I squared times I squared, which is -1 times -1, or +1. So now we've come to a real number, a positive real number. And so when we get to I to the 5th, we can rewrite this as I to the 4th times I. And we just said I to the 4th was 1, and I is I, so this cycles back to just being I again. So the moral of the story is that I is cyclic. Every 4th power is going to get back to 1. And so we can simplify it. Instead of writing these huge exponents on I, we can always simplify it down to either being I, -1, -I, or 1. So we have I squared we write as -1, I cubed we write as -I, and I to the 4th is 1. So we should never have an exponent on I. We should have one of these 4 numbers. And again, even though it's a letter, it really is a number. So if we wanted to simplify some of these examples given, we have I to the 5th. We already did this one. This is really I to the 4th times I, and we said that was 1 times I, so we just end up with I. Now I to the 43rd, again, this is a really high number, but we can say how many times does 4 divide evenly into 43, and then we write the remainder. So this would end up being I to the 40th times I cubed. Well, I to the 40th, I to any 4th power is going to be 1, and I cubed, we said, is -I, so this just simplifies to be -I. Now I want you to pause the video and try the last 2 examples. In this case, see if you add those exponents together. Again, laws of exponents work the same here. I squared times I to the 6th would be I to the 8th, and since 8 is a multiple of 4, we end up with this just being 1. Likewise with D, I to the 15th divided by I cubed ends up being I to the 12th. Again, 12 is a multiple of 4, so this simplifies to be 1. So this concludes the first video of section 14.1. The next video will discuss arithmetic processes with complex numbers. So we'll talk about addition, subtraction, multiplication, and division.